Okay, so I'm supposed to do 36 and 7.3, which says I need to straighten out what arc length is associated to 225 degrees in a circle of radius 4 feet. So, okay, draw a circle. So I drew a circle.
Put the radius is 4 feet.
Okay, put the radius, it's 4 feet.
And then do the
Got it, 225 degrees.
Okay, so I need 225, which is
Third one.
third quadrant.
almost down.
Yeah.
I would convert it to radians.
Yeah, so
1990.
you can either convert 225 to radians, or you can straighten out that this is 180 plus 45 degrees. Why would I think about it that way?
Because it's easy.
180 goes to here, right?
Yeah.
And then 45 degrees more gives me my reference angle kind of automatically.
Why wouldn't we just go to, oh, okay.
Yeah, pi plus pi over 4.
Okay. You don't, or how come you don't just write out where, or 225 is, you don't,
I'm just trying to make a good picture.
oh, okay.
And if I was doing other things, I maybe would want that reference angle. So why are you converting to radians?
Because the formula for sector length only works in radians.
Good. So, right, I'm thinking arc length, right? That clues me into S is R theta, yeah?
Yep.
Okay. I would like my units on arc length to be feet, right? What are the units on the radius?
Whatever you want to be.
No.
Well, for this, feet.
Yeah, on this they're in feet, right? So if I put degrees in here, right, I'm going to get degrees times feet. I don't know what the hell those are.
Foot degrees.
Yeah, foot degrees. I don't know what that means, right? I want it in feet. Radians don't have any units on them, right? So those are what I want. So I need to convert my 225 not into 180 plus 45, but really into radians. So how do you convert to radians? You take 225 degrees
Times
pi over 180.
Yeah.
and you multiply by pi over 180. And then what?
And you find
Okay, so the degrees onesie out, right? And then you can simplify. So what do you get when you do this? 5 pi over 4. Which I really got up here, right? So I really had, this is pi plus pi over 4.
Yeah.
What do you mean, can you do that? Yeah,
Yeah, that's what I can use.
it's math. Multiplication is distributive, I guess, is what I'm using. Right, if I take this and multiply this one by pi over 180 and that one by pi over 180, that's the same thing as if I took the... Fiddle with the distributive property, you'll find that in there. Okay, so you got 5 pi over 4, then what?
Plug it into the thing.
Yeah, plug it in the thing. So S is 4 feet times 5 pi over 4.
So that was just pi.
And so you get 5 pi feet. Cool?
I have a question. What if it gives you the radians as some like range of number instead of a like a known value, like 3 or 5 or something like that?
Oh, so what if I get the radians? What if my angle's like 3 radians?
Yeah.
Yeah, so if it's in radians, you just multiply. Right?
Just plug
Yeah,
it in.
if the angle you have is already in radians, you can just cram it in this formula and work with it.
Just plug and chug.
Yeah.
Okay.
If your angle's in degrees and it doesn't convert to a convenient angle, who cares? You
Yeah,
just
it's
simplify
just
as much as you can and cram it in.
Yeah.
Leave the rounding up to whoever's using it, right?
Okay.
You guys see
You
that?
can just cram it in, give the actual decimal, or give an approximation to like the third decimal, or whatever, and then.
I would just leave it and let whoever's building this thing
Oh, okay.
decide their degree of precision.
Okay.
Like, if I'm using this to ballpark, yeah, if I'm using this to ballpark a ballpark, right? Like I'm rolling a thing around to measure ballparks. You guys know that's how those little things for surveying work.
Yeah,
You know what I'm
Oh,
talking
yeah.
about?
yeah, a little wheel.
It's like a little
rolling.
wheel on a
Yeah.
stick and you like walk with it.
Mm-hmm.
Yeah, I mean,
Isn't that basically just a tachometer?
yeah. All it does is record the number of times it's gone around.
Yeah.
And it's just weighted by how big the circle is in circumference. You guys see that? Perfect. So, anyway, point is, your degree of precision, right, is going to depend on your application. So if you're walking with this little stick and the little thing on the end, it's not that precise anyway, right? Because you might not be walking in quite a straight line and it's kind of dibble-bobbling up and down. If you're using this for precision machining, then you might want to be a little more precise. Cool? All right.